So good morning. This is Ira Gorlick. It's the end of January 2015, and I've made a lot of changes that I want to go over in terms of the learning community. So first thing I want to point out is this Atlantis learning community, specifically R. Atlantis is now a brand, as a registered trademark, so that's a good thing. I've had to redo my websites a little late recently because of some hacking and malware, but I think I'm getting back to speed. And so today I want to go over what is a learning community. And the way I do this is I'm reading this page. So I'll post it here as a video right here, and then scroll down, and best thing to do is just to do the sound and then scroll down as I go through it. And that'd be the best way to go through it. So anyway, so what's actionable for you on this page is to understand the key foundational activities of a learning community, specifically focusing, filtering, dynamic course updates, and define learning codes. All right, let me look at the camera and say hi. And I want you to begin to see how you could apply this in other areas. So I have some links to some pages here that go into more detail. There's the video. And so the first question is, why do we need learning communities? And the reason is information. That if you think about Newton and Franklin, in their day, they would be able to have read every scholarly book written. That would be impossible today. There's just too much data. I have a little picture of the three wise men, or the researchers trying to figure out what an elephant, the blind researchers trying to figure out what an elephant is, and what the parables suggest, and you can go online and see this. What the parables suggest is that while each one of the researchers' perspective is true, the reality is that their truth is inherently bound up by their physical limitations of perception. So the key here that I'm trying to get across is that you would have to everybody has to admit that we are all to some extent blind. And frankly, there's a lot of good research on that. I've got a picture of Heisenberg here. Essentially, Heisenberg said we have to remember that what we observe is not nature in itself, but nature exposed to our method of questioning. I could also show obviously some matrix stuff of what is the matrix Neo. Will Rogers said it isn't what we don't know that gives us trouble, is what we know that ain't so. And then finally in the Stephen Hawking's, the greatest enemy of knowledge is not ignorance, it's the illusion of knowledge. So I've got 3 steps here to help you manage all the information available. The first step is to recognize that we have limited capabilities. The second step is to ask for help from other people. And the third is to create a method to share all the information from others so the net result is a greater and more accurate perception of reality. So the key to learning, key to growing, the key to making decisions is first recognize that we are limited. Next, recognize we have to get information from other people. And the third one is create a way that when we get this other information from people, we can trust it. Ronald Reagan said, trust but verify. So the summary of this is there is more information than any one person can optimally process. So we need a learning community to help us optimally manage all this information. In other words, we're all blind researchers looking at the elephant. We need others to tell us what it is. The learning community is identified by two specific things. One, it's small groups of individuals that connect with other small groups of individuals. How small depends on the context of the learning desired. And you're going to see why that is when I talk about cell sites and the Keck Observatory. The other thing that distinguishes a learning community is an agreed upon communication process that is intended to facilitate the optimum movement of information between people. If you think about religion and the role that communication is in religion, for example, you have to believe in the Bible. In a Christian religion, let's say we have to believe in the Bible, and there is an agreed upon communication process that is intended to facilitate the optimum movement of information. This is just something we've learned you need to do. So combining these things into a learning structure allows a larger community to maximize its ability to grow and succeed. Now, one of the things that's important is how information moves through a community, or how information fits into this. I've divided information up into 4 distinct boxes. One is the raw data, the original bits. The next phase of once you have the original bits, then you generate combination of bits to create facts, and facts are defined, I'll define them a bit in a second, but facts are defined as something that is verifiable. Conclusion is something we draw from the facts, and then based on our conclusion we take an action. So let me read to you this, because it's easier if I read it. I know I can get it right. And like I said, I've listed it here on the website if you scroll down. What I just said is clearly a high-level explanation, but I want to put on a few modifiers here. Let me read this. If no intent of action exists, then the effort should not be made. If you know you are not going to change the way you drive to work, there is no reason. Oh, I spelled there wrong. So, if you have no intent, if there is no intent to action, in other words, if you know you're not going to change the way you drive to work, there is no reason to research different ways to drive to work. So the modifier of all this is don't go through this process if the result is not some recommended action. Now, I want to go into that in more detail later, but be that as it may. All right, next modifier here is there will always be more data than you can optimally store and process, so accept that you will not get it all. So recognize that when it comes to the raw data, get as much as you can, as much as optimal. We'll talk about the information sweet spot in another section. All right, the next three go together. Data, the raw data is objective. Data can be stored as ones and zeros in the computers. Multiple copies can help determine its objectivity. In other words, you're watching this on video. This video represents an MP4 file. There exists on my computer an MP4 file. I can make exact copies of that MP4 file. That's the raw data. That is objective. You can figure out whether it is the raw data or not. Then you have facts. Now, facts are somewhat subjective, and we need to go into a lot of detail because this is somewhat argumentative. So since facts are somewhat subjective, there must be a method in place to remove all or at least some of the subjectivity. Facts are what's verifiable, but as Heisenberg pointed out, we have a trouble measuring things because the act of measuring it is going to change it. It's sort of like, if you have a small cell and one person is in that cell, can another person enter that cell without affecting the first person? And the answer is no. So the act of being human, the act of doing what we do is going to change stuff. So they're somewhat subjective, but we try to make them objective as possible. And then finally, conclusions. Oh, and back when they say they're somewhat subjective, to the speedometer of your car. We know the speedometer of your car is fairly accurate. Usually you can tell if you're going 80 miles an hour versus 20 miles an hour, but its precision is limited and to our own perceptions. And then finally, where data is totally objective, facts are somewhat subjective, conclusions are totally subjective. My conclusions of the facts, so like for example, if the speedometer says 80 miles an hour, my conclusion that that's fast or slow is my conclusion, and it's totally subjective. Someone else can have a different conclusion on that fact and come to a different, someone can look at the fact that I'm driving 80 miles an hour and come to a different conclusion on whether that's fast or slow. And then finally, the most important piece actually in a lot of ways is the actions test the process. If the actions yield the desired result, then the conclusions can be considered valid. So in other words, if I make a recommendation, if I look at the data, get the facts, draw a conclusion, and then take a recommended action, the action should be what I expect. If it isn't, then something's wrong. All right, let me use just two quick examples of physical learning communities. Telescopes, I like this. This is a picture of the Galileo telescope. That originally it was just a lens, and then that worked fine. But as soon as they got too big, the lenses started to warp. So then they went to a mirror and a refracting telescope. I have a picture of the Palomar telescope. I think this is the one that Edwin Hubble just came up with his theory that the universe is expanding, and that's a refractor, but even that can only get so big. So now here I have a picture of the Keck Observatory where they start linking together mirrors, smaller mirrors. They can find that you can get larger surface area by linking together small mirrors and then tying together through communication. The same for cell networks. I have a picture here of a cell network. It used to be you'd have one large cellular footprint over a market, and you could have 6 or 7 calls at a time. But once we were able to break the cells down into individual cells and then link the cells together, we can have virtually unlimited number of conversations. So, applying this to learning, let me read this because I like it. The same can be applied to learning. At one time, a classroom with some books and a teacher was sufficient for any community. One teacher could teach all the necessary stuff a student would need. But as the quantity of information and the ability to access information exploded, having one large class was no longer optimal. The evolution from single-room schools to learning communities follows the same evolutionary path as telescopes and cellular networks. Rather than having one large learning institution, we need to break learning into a lot of small communities. Each one can then focus on more narrow interest. Of course, the trick is linking all these communities together. Again, this is where telescope and cellular networks are informative. The way both of these technologies accomplish the linkage is through a communication standard. Once the standard is defined, the number of cells or learning communities that can be linked together become quite large. It may even be infinite. So in summary then, just as the telescope and mobile networks found that breaking down the information processing to small cells and linking the cells together, so too can learning be improved by breaking the learning down into small communities of interest and then linking those communities together. The learning community architecture is made up of three fundamental activities. Filtering and focusing, that means concentrating on the important stuff and breaking out the noise. Dynamic course updates, which means improving the courses continually. And then the defined learning communication codes, which standardize the way people share information. While traditional education uses these same activities, it's the use of 21st century electronic tools that sets the learning community apart from traditional education structures. Using the 21st century tools allow the community to implement this new educational paradigm. Here's a link to a post that would provide some additional, so let's see, I have a post link here. Okay, so here's the 5 reasons why schools can and should be different today and why it's important. And I lay out a pretty good explanation and justification here. I've used some TED Talks that are indicative of what I'm talking about. That'll give you some insight. I say, one, schools have access to virtually infinite amount of information because we have domesticated the electron. I say religious and political structures are no longer a monolith. I say basic needs are not the focus anymore. I say the traditional period of knowledge has become a network of knowledge. And I say diversity is the rule and not the exception. So check that out. Go back over to our learning community. Okay, so now the 3 aspects of a learning community: filtering and focusing, dynamic course update, and then define learning codes. I'll go over that just briefly here. So filter and focusing, think about gold miner. The mountain is all the data, and you have to mine the gold to get it out of mine the gold to get it out of the mountain. So that's the data, these are the facts, and then this is the conclusions that one draws. So you've got a lot of data, a little facts, and then they make a product. Dynamic course updates, let me read this because I think it's interesting. Dynamic course updates is the process where the benefits of filtering and focusing are stored and paid forward to the next class by updating the course real time as each learner contributes to the class. In the past, a class would be created and taught to successive classes virtually unchanged. Any learning that might have occurred is lost the moment that learner leaves the class. And not only in the past, that's the way I'm teaching classes as we speak for DeVry and Keller. Rather than seeing individual learning as the end product of a class, a learning community sees the end product as the overall learning of the community. In a learning community, a learner and teacher are both contributing to the entire educational process. The goal of the learner is not only learn for themselves, but also to contribute to the learning of all other learning community members that come after them. All right, and the third piece is the define communication codes, are the specific meta-communication codes used by the learning community to move bits of information between learners. In order for optimal learning to occur, the members of the learning community are better served if they use an agreed-upon method of communication, which includes syntactic, semantic, and cultural codes. This is exactly why scientists use the scientific method. Then in summary, a learning community is set up to seek out new knowledge and add that knowledge to the total accumulated knowledge of the community. Every learner is encouraged to, not only find new learning that helps them personally, but new learning that helps the entire community. In that way, classes are dynamic in the extreme. Each new learner taking a class should be able to add value to the next learner taking the class. The idea that learning exists only in a classroom and disappears as soon as the class ends is an anathema to the learning community. So putting it all together, I've got a little chart here. The idea being, much like the Keck Observatory or cell phones, you've got all these little learning communities around, and what they're doing is they're discovering data, facts, conclusions, and action items. They're then feeding the cloud, which then feeds the various learning communities. And that way, every learning community can benefit. The key that I'm adding to this is that this communication that's going on in here has a standard whereby you can better value the information. So hopefully you like a learning community. There's a lot of stuff, a lot of detail. This was a very high level. Notice I've got a suit and tie, so I'm exploring that as an option. I've got new lights, so let's see if this works any better. Talk to you later. This is Ira Gorlick. Thank you.